not every series adds up in a meaningful way. If they don't add up in a meaningful way, we're going to say that they diverge. For the rest of the semester, we're going to be talking about tests to figure out whether these series are converging, whether they're adding up in a meaningful way, or whether they're diverging. Let's think about this series using partial sums, because remember, that's how we define a series. So the terms of this series are -1 to the 0 plus -1 to the 1 plus -1 squared plus -1 cubed plus -1 to the 4th plus -1 to the 5th, etc. My first partial sum is 1. My second partial sum is 0. My third partial sum is 1. My fourth partial sum is 0, etc. It's a lot less intuitive what ought to happen with this series. If I keep adding, I just keep going 1, 0, 1, 0, 1, 0, 1, 0. And so it's tempting to say, well, the sum should be 1, or the sum should be 0, or the sum should be a half. The reason why we like these rigorous definitions is that they tell us what to do in these ambiguous cases. So what is this? This should be the limit, as n goes to infinity, of my partial sums, should it exist. This limit does not exist. The series I'm looking at goes 1, 0, 1, 0, 1, 0, 1, 0. That doesn't have a limit. Since the limit of the partial sums doesn't exist, this series diverges. So again, having this very rigorous definition takes away the ambiguity about what ought this to be. Well, according to this definition, according to the definition we're using, this is a divergent series. It doesn't add up to one number in a meaningful way. Now, if you've noticed this block of text up here, there's something called the divergence test, and it's a quick way of sometimes identifying series that diverge. I take the things that are being added, these a sub n's, and I take their limit. And if the limit is anything other than 0, the entire series diverges. So what we just did now was we used the definition of a series in order to figure out that this diverges. But instead of using the definition, we could use this shortcut rule. My a sub n's, the terms that are being added, are -1 to the power n. The limit as n goes to infinity of a sub n's does not exist. In particular, it's not 0. So, by the divergence test, our series diverges. Again, the first way we found this was by using the definition of series. The second way was by using this divergence test. The partial sums for this series are a little hard to figure, but this one actually has some good intuition behind it. The terms of this look like a 10th plus 1 over 2 to the 10, plus a 10th plus 1 over 2 to the 11, plus a 10th plus 1 over 2 to the 12th, etc. And 1 divided by 2 to the 10 is pretty small. It's like 1,000th. So these terms with 2's in them, these are getting pretty small. So what this is kind of looking like, as n gets really big, this kind of just looks like a 10th, plus 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 a 10th. And if I keep going infinitely long, I can see this isn't getting closer and closer to any one number. This is just piling up. This limit is going to infinity. So I can see that the limit as n goes to infinity of my partial sums is infinity. So that tells me my series diverges. And by the way, we often do this kind of shorthand where we omit the bounds if they're not particularly important at that minute. So that would be using the definition of a series. The definition of this series says we should take the limit of the partial sums. My partial sums are growing without bound. A 10th plus a 10th plus a 10th plus a 10th plus a 10th. Give it enough time, it'll get as big as you like. We could also have used the divergence test. So what is the limit as n goes to infinity of a sub n? So remember, s sub n, those are sums. I'm adding all of these terms. A sub n's are the things that are getting added, and the things that are getting added are getting really close to a 10th. So these terms that I'm circling here, these are my a sub n's, and as n goes to infinity, this goes to 1 over 10. So by the way, This is a good place to stop and make sure that you're up to speed with all the concepts. It should be clear to you the difference between this limit and this limit. If it is not clear, it's a good idea to go back to 8.3 and review partial sums, because if you don't understand it now, it's just going to get more confusing. All right, so this limit is 1/10, and in particular, 1/10 is not the same as 0. So that means our series diverges by the divergence test. It becomes a bit quicker to think about this with the divergence test as opposed to thinking about it with the definition of a series. The terms being added up here, my a sub n's, are e to the power n divided by 2 times e to the power n minus 1. If I wanted to evaluate this, I could divide the top and the bottom by e to the n in the same way that I do with rational limits. And I see that this bit here goes to 0, so my limit is 1/2. So the things that I'm adding up, they're not exactly 1/2, but when n gets really big, they look very close to 1/2. So my sum a few terms in looks like 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. That can't converge to a meaningful number. It's growing without bound. The limit of its partial sums is infinite, but we don't need to go to that trouble. We can just say the limit of the terms being added is not 0. So our series diverges by the divergence test. Now the divergence test is kind of a one-way street. What if I try and apply it to this last series, which has a special name? It's called the harmonic series. The things being added up, the term of the sequence being added, are 1 over n. Those are my a sub n's. This limit is equal to 0. That's not covered by the divergence test. If the terms of the sequence being added are not going to 0, then definitely the series diverges. If the terms of the sequence being added do go to 0, sometimes that happens in divergent series and sometimes that happens in convergent series. So this just means we need another test. And in subsequent videos, we'll talk about what other tests are available to us. Again, to be clear, you're trying to decide whether a series converges or diverges. The terms of the series we're calling a sub n. If the limit of these terms is anything other than 0, my series diverges. If the limit of those terms is 0, you need another test. Sometimes the limit is 0 and the series converges. Sometimes the limit is 0 and the series diverges.